All right, so welcome back to OneClass again. My name is Joey. I'm going to be your chemistry teacher for the next session. So if you were just tuning in for the first time, again, thank you so much for watching. And tuning into the OneClass channel. Here at OneClass, what we're aiming to do is we provide kind of online free lessons and live streams and videos for kind of students at home. So these are topics covering from basically secondary level math to and chemistry towards the college and the university level as well. In this particular session of this hour, what we're going to do is we're going to focus more on grade 12 chemistry. So again, senior level chemistry, and we have about 10 questions to talk about these topics and concepts here. Again, my name is Joey. I'm going to be your chemistry teacher for the session. Again, I come from a background with a secondary school educator level. So again, I have my teachables are chemistry and science, as well as in music. And I'm hoping to get my math teachable further down the road in September. So without further ado, let's get started on today's topics and questions for today. All right, so let's do this. Let's start off with our first question here. It says match the following. It says draw the appropriate labels to their respective targets. And I can't really see these guys here, so I'm gonna have to maybe redraw it here for you all. So this is, I think I've lithium iodide here. This is CH3OH. I have methanol, I can't even see it. CH3. It's just, the font is kind of small here. CH2F2. And LiI plus H2O, and then basically I'm given basically these labels here. Let me see if we can enlarge it. I have H2 plus H2O plus H2O. I have dipole. I have dispersion forces. I have an ionic bond, hydrogen bonding, and finally, ion dipole. So basically what we're going to do is we're looking at this left section and this right section, and we're going to basically match these guys with these terms here. So maybe I'll create some sort of line here, and we can think about where do they belong in terms of which category would they belong in. So let me draw kind of this out here. Oh, whoops. That's not what I meant to do. That's clearly, my lines are clearly bad here. So this would have been, this here was oh, whoops. CH2F2. F2, this would have been LiI plus H2O here, and then I can erase this guy over here. Okay, so we have, let me rewrite this actually, it's kind of messy here. So CH3, right? CH3, let me rewrite this as CH3OH here. This is methanol. Okay, so I have all these guys here. So take a moment to think about this question. Again, what would match these compounds here? So let's take a moment to think about this. Again, think about what are dipole. This is the concept of intermolecular forces. What are dipole forces? What's a dispersion force? What's an ionic bond? Hydrogen bonding and ion dipole. So think about these problems for a minute, and then we will take up our answer like so. Okay, so let's do this problem here. So so this is lithium iodide, right? So lithium iodide, again, this is lithium iodide. Lithium is a metal, iodine is a non-metal, which means this would make an ionic bond. So I would have to erase this, and my first answer for this problem here would be an ionic bond, right? This would be ionic bond. I have a metal and a non-metal. Good. Let's look at this one here. CH3OH, this one would not be dipole. This would be an example of hydrogen bonding. And how do I know it's hydrogen bonding? Well, if I were to draw out the chemical compound here, I have C, I have C bond O, bond H, C bond OH, and this is H, and H over here, right? So if I have, this is the chemical structure of methanol, and basically what I have here, this O is bonded to this oxygen here, right? And this oxygen again has lone pairs here. This is an example of hydrogen bonding. This has a hydroxyl group at the end here, and this H bond is very attracted to this oxygen here. So this here is a concept of hydrogen bonding, right? Again, it's the strongest intermolecular forces besides an ionic bond. So this here was as an example of hydrogen bonding. That's good. Number 3, this is CH3CH3. This is an example of dispersion forces, right? This is London dispersion. And I erase this because I want to write this in red. This is London dispersion. And the only reason why is if I were to, again, draw out the chemical compound of CH3CH3, you're going to realize that I get something like this. There's no dipole moments here. There's no ions here. There's no hydrogen bonding. Therefore, the only forces that exist here are dispersion forces, right? Again, dispersion forces usually are just it depends on the atomic size of the molecule, and basically it's just the electrostatic forces that exist in the molecule here. So these are dispersion forces because I don't have a dipole moment. CH2F2 here would be a dipole force, right? This here would be dipole, and the reason why it's dipole here is because I have a dipole moment between carbon and the fluorine here, right? So let me redraw this out for you as well. So again, I have a carbon bond carbon. I have one carbon only. Bond. This is bond fluorine, and then bond H and bond H. There's a dipole moment between, again, the fluorine here is partial negative, very electronegative, which makes the carbon here partial positive, right? So then again, there's a dipole moment between these two guys and these two guys here. This is a dipole intermolecular force here. So CH2F2 would be an example of a dipole force. And finally, lithium iodide plus water would be our ion dipole, right? This here would be our ion dipole, because I have a polar molecule such as water. Water is a polar molecule, and again, I have a cation or an anion as an ion, which is lithium iodide here. So in this sense, we have a dipole, right? So for example, if I were to let me erase this part here for you. What I have here is if I had lithium iodide, and this dissociates, so lithium iodide we dissociate to lithium positive and iodine minus, right? And this here, as along with the with water, if I bond water here, again, this here has the ion dipole, right? This here was a positive charge here. And then my partial negatives would come from the oxygen here, right? My partial negatives. Again, I have this as an ion here and a dipole here. Therefore, this is an ion dipole intermolecular force. So this here would fill up my chart here, and let's see what they have here. Therefore, okay, so let me just scan this quickly. So they're just talking about dispersion forces, dipole, ion dipole, and hydrogen bonding. Dispersion are the weakest intermolecular force that's good. At present, nonpolar molecules. CH3 is a nonpolar molecule. There are no dipole moments. Hydrogen bonding is the strongest intermolecular force and represents a special class. So it's hydrogen bonded to nitrogen, oxygen, or fluorine. In this case, it was bonded to oxygen. So this here is an example of hydrogen bonding. Ion dipole is simply just a dissolution of an ionic molecule, so lithium and iodide, in a polar solvent such as water. And then we have the major forces coming into play when an ionic molecule is dissolved in a polar molecule, right? So again, I have a cation of lithium, and it's attracted to my dipole of oxygen here. That's good. And finally, dipole is simply just a dipole moment within the molecule here. So therefore, lithium iodide is our ionic bond good. Hydrogen bonding is in methanol. CH3 is dispersion forces. CH2 is dipole forces, and lithium iodide in water is ion dipole. So this here is the correct answer, and they provided a great solution for all of these guys here. So this here solution is correct. Great analysis. Solution here.